Here we have a parabola-like problem, a projectile problem, where a baseball is thrown and the height of the baseball is modeled by the function given here, h equals negative 0.004d squared plus 0.14d plus 2, and h is the height of the ball in meters, and d is the horizontal distance of the ball from the player in meters. So even before I start answering any questions, I'm going to draw just a quick little sketch of what's going on here. Here is my ground. Here is my player. He has a baseball in his hand. I know I am such an amazing artist. He throws the ball up in the air. This is the path it takes. It's parabolic, and it comes and it hits the ground at some point. So that is just my visual representation of what's going on. I'm now going to start to analyze the scenario and answer a variety of questions relating to it. So the first one is, what is the maximum height reached by the ball? In other words, if I look at my picture here, the maximum height is, what is this topmost point of the ball? What is this value here? And if you haven't noticed already, the path that the ball traces out is a parabola. So this question is essentially asking me to determine what the vertex or the y-coordinate of the vertex is in order to determine the maximum height. Now, to find the maximum height, I have to follow the process known as completing the square. So what I'm going to do is I'm going to copy my equation, the original. So I have here d equals negative 0.004, and it is not d, it's h, because d is the horizontal distance, and that's d squared plus 0.14 d plus 2. So let's go about completing the square for this question here. I begin, because it is a complex trinomial, by factoring out my leading coefficient, which is 0.004 negative, out of the first two terms only, and that leaves me with negative 35d plus d squared plus 2. And then off to the side, I take my b value, that negative 35, I divide by 2, square the result, and I believe that gives me 306.25, so 306.25. Again, if you wonder where that number came from, I would recommend you plug it into your calculator and generate it yourself. So at this step, I'm ready to add and subtract that number I found above, so I'm just going to copy this entire line, paste it right below here, and inside here, I'm just going to move this out of the way for a second. I'm going to be adding and subtracting 306.25. So what I get here is plus 306.25 and then minus 306.25. And then I can take this part that I removed off the end and put it back. In other words, I'm just adding 0 in a very fancy way so that what I end up with is a perfect square trinomial. Now, I need to bring outside of the brackets this term here. So again, I'm going to copy the whole expression. All of this stuff remains the same. So I'll just put that there. I close the bracket, but this time when I bring this final term outside, I have to multiply it by the leading coefficient. And what that gives me is positive 1.225 plus 2, which equals, again, the whole thing again that I had above. I can rewrite over here. And if I add those two terms on the end together, I get 3.225. The The last step is just factoring the trinomial that's left inside. It is a perfect square trinomial, so the factorization will be pretty straightforward. It becomes d minus 17.5 all squared plus 3.225. So all this work to determine what our maximum value is, and now that we have it in vertex form, we can see that the vertex is going to be 17.5 and 3.225. So this is our vertex. And if I look at this point on my graph, on my grid here, it's this point that I'm talking about. So I'll just, to save time, I'll copy this. And then I will put it over here, shrink it a bit. And the maximum height is the y-coordinate, or 3.225 of my vertex. So to answer part A, what is the maximum height reached by the ball? The maximum height is 3.225 meters. What is the horizontal distance of the ball from the player when it reaches the maximum height? Well, that is very easy to answer because we've already calculated it. Remember, this here, where the ball is released, is the horizontal distance of 0. So when the ball reaches the maximum height, the horizontal distance is the x-coordinate of my vertex. In other words, it's 17.5 meters. So 17.5 meters goes into here. And I've already answered the second part. How far from the ground is the ball when the player releases it? Well, if you look at your initial equation, the horizontal distance when the player releases the ball is 0. In other words, what this question is asking in part C is, what is the y-intercept? And if I look at the equation, I'll take, say, this version here, the standard form version, and I plug in 0 for d over here and over here, what I find is that the sum of these two terms will be 0 plus 0, and if I add 2, I get 2 as my y-intercept. So if you want to do that in terms of equations or whatever, you just take your standard form, and I think we have enough space over here to show the work. I take my standard form, I replace the d's with 0, so I get 0 here, and I get 0 here. Becomes 0 plus 0 plus 2, and I get 2 as my initial height when the ball is released. Part D, how far does the ball travel horizontally before it lands on the ground? So I'm looking for the point where the ball lands on the ground. It travels horizontally from 0 up to who knows where this is. I mean, that's what I'm trying to find. And what it looks like in terms of a Cartesian plane is, well, what is the root of that parabola? And finding the root, unless we can factor it, which in this case, dealing with decimals, I wouldn't recommend because it's very hard for the human brain to calculate, I would recommend using the quadratic formula. So for part D, how far does the ball travel horizontally before it lands on the ground? I say we use a quadratic formula. And that is, in this case, not for x, but I'm going to do for d, equals negative 0.14. So that's my b value, the negative of it, plus or minus the square root of 0.14 again, squared though, minus 4. My a value is 0.004. My c value is 2, and that is all over 2 times negative 0.004, close bracket. Once I do all the calculations, and I'm not going to bother to show them here, I end up with two values. One is a negative 10.89, and one is 45.98. Now of the two, 45.98, Of the two, I choose the positive one because I'm looking at the positive distance of where that parabola touches the ground. So if I go back to my diagram here, okay, so there is 0. This here would be 45.89 meters. The negative value doesn't come into play, but if we were to see where it goes on the parabola, it's obviously somewhere back here. In other words, if the ball were continuing in the other direction, it would land at negative 10.89 meters behind the player. Okay, so I can write that in for the answer to part D, 45.89 meters. And finally, at what horizontal distance will the ball be 3 meters above the ground? So what I have to look at here is, I know my max is 3.225. 3 meters, if I were to look at it pictorially, is going to be somewhere around here. So the question is, at what horizontal distance? In other words, if this is 3 meters, when is the ball going to be at that 3 meter height? In other words, where is this value and where is this value? So in this case, what I do is I replace my vertical distance, my h, with 3 and try to solve for d. What does that look like? So I'm going to put some space over here. I have my 3, that's my height, and then I just use the same equation. So let me get the equation from over here, copy it, and I'm going to paste it right here. Get rid of these underlined D's. And what I'm doing is I'm trying to solve for D. Now, that 3 on the left-hand side has to come over. So if I bring the 3 over, I have the whole thing identical. Only difference is that it's going to be not plus 2. It is going to be minus 1 because 2 minus 3 is 1, and I'll have a 0 on this side. So there is my new equation. And to find the roots of it, well, again, unless you can factor this, which I highly doubt, I recommend using the quadratic formula. So once again, let's plug our values in. Negative 0.14 plus or minus the square root of 0.14 squared minus 4 times a value is negative 0.004 times negative 1, running out of space, all over 2 times negative 0.004. Okay, again, I'm going to leave all the work for you to do, but what you get in the end is 10 and 25 meters. What does that mean in terms of our picture? Well, at 10 meters, which is right here, the ball is 3 meters above the ground, and at 25 meters, once again, the ball is 3 meters on the ground on its way down. Here is our midpoint, 17.5, and you can see how both the 25 and the 10 are the exact same distance from the center, 17.5. They're both 7.5 meters away, and this is just shows that the symmetry of the question corresponds to the reality of the situation, which is ideal. Okay, this is perfect. This is what we want to see when we're solving. So that's a very involved question. You got to break it down step by step, but it is doable. Just, again, use the picture as a guide for your intuition, and always fill in the information as you go along to help you arrive at the answers that you're looking for.